Okay, let's look at this North-Sydney boys pulley question, which I think is probably the hardest one I've ever seen in extension 2. As usual, you can pause the video to do it first by yourself. Okay, let's read through the questions. So basically, there's a system like this, and you can see that why it's complex is because you have two pulleys, and this one is fixed, but this one is moving. So now let's analyze the force, as always, how we approach these questions. So when there is a string and it's light and inextensible, then the two tensions on both sides should be exactly the same. So let's start from here. If there is a tension and there is a tension, then they are the same, right? So we also know the gravity, so we finish analyzing both of them. Now we need to analyze this. So here it should be 2t because it's t here, so it must be 2t. So if here's 2t, then here's 2t, so there is mg. Now we've done the force, it's down. Now we need to analyze the acceleration, so we let the acceleration here be a as required in the question. Now the most difficult part about this question, if you gave a thought about it, is the fact that you know how this one is moving relative to P1, is moving relative to P1, but P1 is also moving. So the acceleration needs to add up these two accelerations. So I'll let this be A2 moving downwards, and this must be moving up. A2 also, right, at the same acceleration because they're connected by an extensible string. However, we need to know that the A2 here is with respect to Q1, so it's moving up with respect to P1, sorry, the first pulley is moving up with respect to P1. However, P1 is also moving up, so you need to add up these two accelerations. Now I think we can move to the next step. So let the acceleration of m be p, and let the acceleration of m2 be a2. And yeah, so basically how I just said, if this is a2, then this must also be a2, because let's treat them not as vectors. It's just a quantity. We don't care about the positive or negative because it's very clear how in the question they didn't say it's absolutely positive, so you can think that it's all positive. Now we can just set up the equation. Here the first one is quite straightforward. The only thing I think you need to be aware of is, since it's moving downwards, then it's gravity minus tension, because tension is because you treat the acceleration as always positive. So since acceleration is downwards, then you and gravitation is downwards, so you use gravitation to minus the tension. Now these two are a bit more tricky because as I just said, it's moving relative to P1. M1 is moving relative to P1, but P1 is also moving. So look at M1. M1 itself is moving up, P1 is also moving up, so you can add them up together. And since it's moving up, you use tension to minus gravity. And for M2, it's exactly the opposite. The whole thing is moving up, but this is moving down. So you need to use the upwards to minus a2 like this, and however it's still moving up generally, so do this. This is how you set up the equations, and after you set up the equations, it should be easy. We need to get rid of t and get rid of a2. We first get rid of a2 because it's very apparent this plus a2, this minus a2, we can just multiply by some terms and cancel them out. So this is how I manipulate 2 and 3. We multiply by m2 in 2, and we multiply by m1 in 3, and we cancel out the term. So we get this relationship. Now we want to cancel out t as well, so we multiply a term in the first equation to get this. Now we add them up together so that we can cancel out t and reach the actual what they want in the question. It's very apparent. I don't put much effort in from this step to this step, because for a majority of the extension 2 cohort, it shouldn't be the hard step. It's the only hard step is how to set up this. It's the hard part. Setting up is hard. Things you need to remember. First of all, it's very clear when there's multiple pulleys with respect to which, and you add up to, if you want to know A2 with respect to P, you can know A2 to P1 and P1 to P, then you know A2 to P. So that's how you do it, and you mind the direction, because I always stress direction, because you need to know which minus which, and if you know they're treating everything as positive, so acceleration is always positive apparently in this scenario, so you need to know the direction of the acceleration, and if it's moving downwards, then you minus the upwards one, vice versa. So these are the two things you can learn from this question. Lastly, it's just some of my personal lament about this question, because it really shouldn't be in math, it should be in physics. But since they are too reluctant to put these math and integrals into physics, which they should, because that's a part of physics. Isaac Newton, the founder of modern physics, he came up with all these calculus, so they should put these into physics, but they didn't, so we need to do it in math extension 2. So it's actually, I think it's a pity, but look at this, who would put this in a math exam? But that's how it is, and we can only just do our best. So if you like this video, please subscribe and like this video, and thank you.